Hi, I'm from Veltech Technical University and this is my BTech Mechanical final year project. We have done our final year project from Continental Engines Limited, and the project being assigned to us is three-wheeler IDC simulation for steady state testing. The members being involved in this project are Lalit Kumar, registration number 10UEMEA0067, and Ravi Kumar Singh, the registration number 10UEME0101. Before we proceed further, we should know about the Indian drive cycle. Indian drive cycle is a sequence of measured data points under several vehicle operating conditions like idling, acceleration, cruise, deceleration, braking and gear changing, which is a representative plot of driving behavior in a given city or region. Automotive Research Association of India, that is ARAI, collected extensive data in major cities to develop a standardized driving cycle, and this driving cycle is known as the Indian driving cycle. WLTC Class 2 cycle. WLTC has three classes. First class is for the heavy vehicle, second class is for the light vehicles, and third is for the regular vehicles. What is WLTC? WLTC is a worldwide harmonic light testing cycle, that is light vehicle testing cycle, and this is a plot between vehicle speed and time. We have done the coast down test for determination of the road load constants, and this is the commercial vehicle motor vehicle report by the ICAT. We have done the performance test, and the test procedure was the IS147852000, and the given data were equivalent inertia and engine capacity, that is 499 cc. And these were the observations being done during the report, and the 5 readings were taken of speed, force and force curve. These are the gear shift which is being preferred by the company, and ICAT prefers some different gear shift, but approximately they are the same. Upshift for first gear is 0 to 9 kmph, second is for 10 to 18, third is for 19 to 28, and fourth is 29 to 42. A and B are being calculated as per these formulas, and these are the road load constant, and the equation being used is F is equal to A plus BV square, where A and B are road load constant, F is equal to road load in Newton, V is the test speed in kmph, and N is equal to number of test speed. And these are the calculation for the calculation of the road load constant and force exerted on the vehicle. We got the B value as 0.065 and A value as 75.40. Curve fitting error is 0.63%. Now we will calculate the engine HP, engine RPM, engine torque at each instant and plot the graph with respect to time when vehicle is running on IDC. And this is the formula as this force being exerted on the vehicle, and this is the formula given by the ICAT, which is in Maniso, and references are being taken from the traces as per the company. This is a plot between velocity and time. This is the standard IDC graph which is being plotted between velocity and time. As a vehicle accelerates, the graph goes on, and the decelerates and gear shifts, the velocity decreases as the vehicle decelerates. As you're seeing here, the first gear is being put between 0 to 9, and second is between 10 to 18, and third is between 28 to 38, and fourth is nearly to 42, and then vehicle decelerates. Now the force is being calculated by this formula, where V is equals to final velocity and U is initial velocity. This is the plot between force and time. And then we have calculated wheel RPM and torque. V has been calculated as pi dn by 60, and then we have calculated the wheel RPM where d is equal to d is equals to tire rolling diameter in meters, n is the frequency of wheel in rpm. And then we have calculated the torque, which has been calculated as the product of force and the rolling radius of a tire. Then we have calculated the wheel HP by the formula rpm into torque by 5252, where torque in lbft, that is pounds feet, and 1 newton meter is equals to 1.355817 lbft. And this is a plot versus wheel HP and time. Then we have determined the engine rpm, and these are the overall gear ratios which has been given by the company. RPM of an engine has been calculated as the RPM of a wheel into overall gear ratio, where overall gear ratios are being mentioned here for the first gear, second gear, third gear and fourth gear. Loss percentage of HPV plus HP wheel, which determines the engine HP, and these are being considered as given as shown in the video. This is the plot versus engine HP versus time. Then we have made a cluster which will represents the whole data, and the regression analysis done on this cluster. Then we have calculated the weightage and weightage factors. Then we have calculated the 15 points on the basis of this analysis, and which will determine the 97% of the cluster. These are the procedure for the selection of the weightage, that 15 points at different RPM and at different HPs. NOx emission. Possible causes of high oxides of nitrogen emission. In order to pinpoint the cause of excessive NOx emission, the following systems and possible defects will need to be checked, usually in this order. Over advanced ignition timing, adequate exhaust gas recirculation flow, lean air fuel ratio, defective three-way catalytic converter. All these factors are the causes of the NOx formation. Exhaust gas recirculation. In internal combustion engine, exhaust gas recirculation is a nitrogen oxide emission reduction technique used in petrol, gasoline and diesel engines. EGR works by recirculating a portion of an engine's exhaust gas back to the engine cylinders. In a gasoline engine, this inert exhaust displaces the amount of combustible matter in the cylinder. In a diesel engine, the exhaust gas replaces some of the excess oxygen in the pre-combustion mixture, because NOx forms primarily when a mixture of nitrogen and oxygen is subjected to high temperature. The lower combustion chamber temperature caused by EGR reduces the amount of NOx the combustion generates through at some loss of engine efficiency. And these are about the exhaust gas recirculation. These are the physical parameters which is being used in the calculations. Airflow rate. Airflow rate is a measurement of the amount of air per unit of time that flows through a particular device. Mass flow rate. Mass flow rate is a mass of a substance which passes through a given surface per unit of time. And this is the displacement formula. This is a displacement of an engine. Volumetric efficiency. This is an important parameter which has been used in this project. Volumetric efficiency is a ratio or percentage of what quantity of air fuel mixture enters actually the cylinder during suction process to the actual capacity of the cylinder under static conditions. Your engine will not use the full volume 100% because of the friction losses and the leakage. Volumetric efficiency above 100% can be reached by using forced supercharging or turbocharging. This is the formula for the volumetric efficiency: 3456 into cubic feet minute by cubic inches displacement into rp. This eventually we have developed the Excel software by the physical parameters and different analysis. Thank you.